Okay, class. Can I just check with you? What is the method for work the example 13, part A and part B? Drawing a graph, right? So we've already got a graph of cosine 2x, y equals to cosine 2x. Then for part A, using a graph of y equals to cosine 2x, how do you find the solutions for cosine 2x equals to 0.7? You draw a line. What is the equation of that line? Y equals to 0.7. So the intersection point will give us the solution. What about part B? For sine x equals to cosine 2x. We've got the graphs of y equals to sine x. We've also got the graph of y equals to cosine 2x. Where they intersect will be our solution for sine x equals to cosine 2x. What is the underlying principle behind this approach? Intersection point. Okay, what about intersection points? Huh? Yeah, intersection is the solution, but what is the whole idea behind it? Which I learned in Sec 1. When two graphs intersect. Simultaneous equation. Am I right? That is the whole idea behind this. Now we're going to break up our part C into two parts. Because you have to keep in mind, we already have the graph of y equals to sine x. We have and y equals to cosine 2x. If I were to solve equation 1 and equation 2 simultaneously, I will get sine x equals to cosine 2x, which is the question for part B. Right? If I solve that simultaneously. Now I want to be able to do it such that I can end up at this equation. Okay? Or you can look at it the other way. I want to break up this equation over here into the sine x and the cosine 2x portions. So this is the approach. The question is, do you want to make use of your existing sine x graph or your existing cosine 2x graph? Why? Why do you want to make use of your existing cosine 2x? Which one more difficult to draw? Sine x or cosine 2x? Cosine 2x a bit harder to draw because you have two complete cycles within 0 to 2 pi. So let us keep cosine 2x. In other words, let us make cosine 2x the subject. So here, making cosine 2x the subject, we end up with sine x minus 1. Okay, then we say that, hey, I've already got y equals to cosine 2x. It is drawn already. What is the other graph that I need to draw now? Yeah, now I need to draw the graph of y equals to sine x minus 1. Draw or sketch y equals to sine x minus 1 to find the intersection points. Since we already had y equals to sine x, what must we do to the graph of y equals to sine x to get y equals to sine x minus 1? Move up or down? We can choose to move the x-axis or we can choose to move this graph of y equals to sine x. But because we are already keeping our graph of y equals to cosine 2x, I cannot change the x-axis anymore. It's fixed there already. Because I have an existing graph that you wanted to use, y equals to cosine 2x. Therefore, I will need to shift my graph of y equals to sine x down by 1 unit. And we will therefore end up with the graph as shown in page 252. They shifted the graph of y equals to sine x down by 1 unit. They realized that it cuts only at 2 points. And therefore, those are the two solutions. They did not ask for the value of x. They asked for number of solution. Can you imagine if they ask you to use your graph to give them the solutions, to give the value of x? It will be very inaccurate because all our sketches are horrible, right? You're not a computer. You can't sketch a perfect sine graph. You can't sketch a perfect cosine graph. Therefore, For these three questions, we are only interested in number of intersection points. They're not asking for the values, unless they are very special angles. Can? So now, practice now 13. Who needs help with part A? Raise your hand. Practice now 13, part A. Okay, part B. And part C, who needs help? Practice now 13, part C. Okay, after my explanation, you should have an idea of how to do it. I give you 2 minutes to try. Draw the graph of
Cosine x.
y. Draw the graph of y equals to cosine x, as well as the graph of
Y equal to 1 plus sine 2x. Sine 2x plus 1.
y equals to
Sine 2x plus 1.
sine 2x plus 1. Those talking ones are the ones who don't need to listen, right? Because you know very well what to do. Do you agree with what Darius said? Agree?
Yeah.
Okay, which one do you want to draw? Can. Yeah, draw a dotted line for you already. Which one do you want to draw first?
Draw y equals to cosine x.
Okay, you want to draw y equals to cosine x.